So Kepler's first law. Pretty cool. Suppose the particle moves through the space so that its position vector is given r. We know that. We know the limits. We know that it gives us approximation of a tangent. Then we can find exact tangent, the magnitude. We just learned all of this. So it's basically summarizing what we learned. There's a curve. We learn how to describe it. R is pointing in it. And it's keep pointing, and that's how we keep describing it. Now we know there's a r prime. That's the tangent. Unit tangent, let's divide by r prime of size of r prime. And so on. So we learn lots of cool things. Velocity will be, wow, r prime. What a surprise. So let's write down this formula. You don't have to write down the limit definition. The limit definition is how it was derived. But basically, velocity is r prime. We knew it before. It's called velocity vector. Before it was not called a vector. This time velocity has a direction called velocity vector. It has direction and magnitude. So the velocity vector v at a time t. Velocity vector is also the tangent vector, and it points in the direction of the tangent line. How do I find the speed? So velocity and speed is not the same thing. Velocity has direction and it kind of moves things, right? So speed is how strong the velocity is, which means what? The magnitude. Good job. So you have this kind of intuition, right? What it means. So velocity vector is v, but the speed will be size of v, which is size of r prime. Size of v, or the size of r prime. So if they ask you to find velocity vector, vector gives you a hint, you'd find r prime. If they ask to find speed, speed is 50 miles per hour. It's not a vector. It doesn't have direction. 50 miles per hour is 50 miles per hour, no direction. That is the size of the vector, velocity vector. This is appropriate because we have this definition that v is ds over t, rate of change of distance with respect to time. So again, 50 miles, s is distance in miles. Per hour, t is time. Make sense? Miles per hour. Per means derivative. So, for example, miles per hour. That's just an example. Miles per hour. Per. This slash is per. Per means derivative. Miles per hour. In this case of one-dimensional motion, the acceleration will be what? A second derivative of r. So we kind of know it from Calculus 1, and that's why I like this chapter. It just takes you back to the first dimension and expands the idea into the vectors. So this is a nice sketch. I like it. R derivative gives you v. V derivative gives you a, which is second derivative of r. And then if you integrate, you go back. So derivative, integral. From a to, from r to a. Remark, the velocity vector is also the tangent vector and points in the direction of the motion. Acceleration vector points towards the direction of the curve is bending. So acceleration describes the bending of the curve as well, because the first derivative describes the idea of how fast something is changing. The second derivative describes concavity, if you remember, concave up, concave down. So the second derivative, or acceleration, describes or points, it's a vector, it points towards the direction the curve is bending. Bending, that's concavity. That's the remarks I have here. And examples, you're gonna do this basically in your homework. Very straightforward, just 8 problems. I'm not saying it's easy. I know it's rude to say, oh, the homework is easy. Then you will feel bad. No, but it is doable. So this last homework is pretty doable. And we have amazing forum with amazing people ready to help you. So this is a good example or quiz questions. So, oh wow, interesting. Look how it becomes black. Look at that. Exam question. If acceleration is given as a, and it's a vector, 0, 2, 3, can you find from here r? R. If the answer is no, then you get 0 points. Yes, you can. R comes from integrating a twice. That is what we call in calculus 1 initial value problem, IVP. Let me write down on the top. Initial value problem, If you're taking differential equation class, you know that's like a very core of DFQs, initial value problem. Why it calls initial value problem? Because there's initial values, either one or several, are given. So let me tell you that. Find the position R given that initially, that's why it's called initial value problem. And we have some initial values, 1, 0, minus 1, and 1, 1, 2. We need to figure out which one is which. So this is the obvious one, velocity. That means it's initial velocity. Initial velocity has notation v at 0. And it used to be a number in calculus 1. So in this case, the difference is only 1. That is a vector now. And the other one, particle, is at. So the position of the particle was originally given. That is r sub 0. I like to explain this example in calculus 1 using bacteria cells. So if you have several bacteria on the petri dish, we start with 5 bacteria. That's initial r, how many things we had, or the position of them. And then you know the speed, how fast they divide. That's going to be initial v. From there, you can calculate lots of things. So initial value, you always start with something. V will be, so solution. V is the integral of A. And then guess what? You continue integrating one more time. R is the integral of V. So V is the integral of A. So we integrated piece by piece. 0, 2, and 3. Integrate each. How to do that? Well, what is the integral of 0? Derivative of what gave you 0? I heard someone saying constant. You can call it C, but we're going to have many. You can call it A, B, C. We're going to have 3 constants. Or C1, C2, C3. I see in my notes I call A, so let's be consistent. But you can call C1, C2, C3. A, derivative of A is 0. That's what we know. What is integral of 2? 2t plus c, right? So that's called B. And then what is the integral of 3? 3t plus c. So A, B, and C are constants, which we actually need to find. That is because integration does not give you a unique solution. It gives you a family of solutions, if you remember from calculus 1. And it gives you lots of curves. You need to find a specific one. And this is the first time we're doing it in calculus 3 class using vectors. Find A, B, C using, guess what? Initial values, IV. So that's why it's called initial value problem. We have, so what I found here is V. V is A, 2t plus B, 3t plus C. V at 0 is given 1, 1, and 2. That is given, right? They gave us the initial speed. They kind of checked it with speedometer, and that's what they recorded. It's given. Well, and plug 0 into V, you found V. So, but who is so happy over there outside? So jealous. That's a bad joke. V at 0 is A at 0 is still A. 2t plus B gives you B. 3t plus C gives you C. So that's exactly your A, B, C. Be careful, it's not always the case. It's not always the case that they match. If you have exponential functions, trigonometric functions, cosine at 0 is not 0. E to the 0 is also not 0. So that might change. Thus, V at t now has a nice looking formula. A is 1, 2t plus B, that's plus 1, 3t plus C, that's plus 2. That is called initial value problem. We found V out of A by integrating A, and then we had constants, and we found the specific constants using initial value. That's not the end. But because from here we find R with exactly the same step. So that was the step first, I would say. First step, find V. Second step, now find R exactly the same way. Well, R, they ask us to find R, is the integral of V. So integrating a vector. Integral of V dt. And you repeat the process. Let me do that with you. What is integral of 1? People who are talking over there, let me ask you. What is integral of 1? T plus what? Plus C. Let's use C. Or you can use alphabet A, B, C, then D, E, Q. D, E, actually, why do I have Q in my notes? Whatever. I guess I got tired. You can do C1, C2, C3. Let's actually do that to teach you. If you don't like alphabets, then you can use C1, C2, C3. It's infinitely many. Do you know that Russian alphabet has 33 letters? So we have more options than you guys. Can you imagine to have phi? So beautiful. It's phi. Or D. Look at this beautiful D. Oh, yes. Or printed D, even better. Look at that. Or my name is Yulia. So the first letter is U. Look at that. That would be nice. So you can use anything you want. So let's do C1. Then what is the integral of 2t plus 1? 2t squared over 2, right? Yeah. Plus t plus c2. What is 3t plus 2 gives you? 3t squared over 2 plus 2t, correct? Plus c3. And then you just need to find the C1, C2, C3. We know, or given, R at 0 was given. If you go back, you will see it's 1, 0, minus 1. 1, 0, minus 1. Plug 0 into your equation right now. And again, C1, C2, C3 will be 1, 0, minus 1. C1 is 1, C2 is 0, C3 is minus 1. Then, so be careful though, it's not always the case that they match. And we have answered. The answer is R of t, which we found from velocity, and velocity we found from acceleration, integrating twice acceleration basically, will be t plus c1, that's t plus 1. 2t squared over 2, it's going to be t squared plus t, plus c2, that's plus 0. 3t squared over 2 plus 2t plus c3, and that is minus 1. Wow, that is the answer. We did exactly the same thing in calculus 1. We call it initial value problem. Just now those are vectors. That's the whole difference. We're gonna do some fun stuff for next time about the force and second Newton's law and everything. So should be fun on Thursday. Good job, people, for working hard. Exam is on Tuesday. Start preparing.